students. Today we are going to see the point from the radiation chemistry. Units for measuring the radiation absorption. So in this we will see 2 points again, absorption coefficient and absorption in water, and in each we will see 4 sub-points. So let's start with the unit for measuring the radiation absorption. First one is the absorption coefficient. So absorption coefficients are 4 types: linear absorption coefficient, mass absorption coefficient, atomic absorption coefficient, and electronic absorption coefficient. So these are the 4 absorption coefficient: linear, mass, atomic and electronic. So we will see first one. The absorption coefficient. The total absorption of radiation by matter is the sum of mainly absorptions due to photoelectric emission, Compton scattering and the pair production. So total absorption of radiation of the matter, it is the addition of the 3 kinds of the processes: photoelectric emission, Compton scattering and the pair production, which we have seen it in the last lecture. And the energy can be expressed per centimeter length of the matter, or per gram of the matter, or per atom, or the per electron per centimeter square in the path of the beam. So energy can be expressed in the different units: per centimeter, per gram, per atom, per electron, or the electron per centimeter square. So these are the units of energies, and in each type of absorption coefficient the unit is different. So we will see the first, linear absorption coefficient. So simplest expression for the attenuation is given by I is equal to I0 into e raised to minus mu x. So this is the simple equation for the attenuation. Here I0 is the initial intensity which we have provided to the matter. Then I is the intensity after passing through a thickness x of the matter. So x is the thickness. So as we know, we have the curvature whose thickness is suppose x. So we have initially bombarded I0 amount of the I0 intensity light on the matter, and then the light which passes through that matter, that will be calculated, that is capital I. So mu is a linear absorption coefficient. So first point is linear absorption coefficient, and this mu is a linear absorption coefficient, and its unit is per centimeter. And this mu varies from substance to substance. So for each substance the mu is different, or the linear absorption coefficient is different, and the half thickness of the matter, that will be calculated by using equation 0.693 divided by mu. So this is the linear absorption coefficient. Now we will see the second, mass absorption coefficient. So as we know the linear absorption coefficient equation, just divide that mu by rho. So we will get the mass absorption coefficient, and rho is the density. So mass absorption coefficient, that will be given by equation mu by rho, and its unit is centimeter square per gram, and the mass absorption coefficient is nearly constant for all the substances. So equation is given here, I is equal to I0. Again, I is the intensity of the radiation which passes through the matter. Then I0 is the initial intensity of the radiations which we have bombarded on the matter. And here mu is the linear absorption coefficient. D is the thickness which is expressed in terms of the gram per centimeter square. And this rho is the density. So this is the equation of the attenuation. So mu by rho is the mass absorption coefficient, and this equation, when we have included the mass absorption coefficient in the equation of the intensity. Now, the transmitted energy is given by, so E is equal to E0 into e raised to minus mu d divided by rho. So, this equation of the intensity that will be written in terms of the transmitted energy. So, here E0 is the initial energy, capital E is the residual energy that was obtained after passing through a layer of matter of the thickness d gram per centimeter square. So, matter's thickness is given here d gram per centimeter square, and when the radiation passes through that matter, its energy, which is a residual energy or the remaining energy, that will be capital E, and initial energy of that radiation is E0. Hence, the energy absorbed by this layer of matter that can be calculated as we know the incident energy and the emitted energy, but how much amount of energy that will be absorbed by that matter, that will be calculated as a energy of the absorption. So, energy of absorption is equal to E0 minus E. So, E0 is the initial energy and capital E is the emitted energy. So, initial energy minus emitted energy, remaining energy will be absorption energy. So, that equation will be E0 in a bracket 1 minus e raised to minus mu d by rho. So, mu is the linear absorption coefficient, d is the distance or the thickness of the matter, and the rho is the density. So, provided d is small, means the matter thickness is very small, that is for a thin layer, the expression simplifies to when the d is very small and the layer is very thin. At that time, the equation of the E absorption that can be written as E0 or into mu d divided by rho. So, E absorption is equal to the initial energy into mu d divided by rho. Again, E0 is the initial energy, mu is the linear absorption coefficient, d is the thickness of the medium, and rho is the density. So, this is the final equation of the A absorption when d is very small. Then we will see the C, third kind of the atomic absorption coefficient. So, in this atomic absorption coefficient, here the absorption of radiation per atom of the stopping matter is related to the number of atoms per unit mass of the matter. So, simply the absorption coefficient that will be measured per atom or the per unit mass of the matter. So, here small a represents the atom and the mu is again a linear absorption coefficient, and when we combine the atom and the linear absorption coefficient, we will get the atomic absorption coefficient. So, simply AU represents the atomic absorption coefficient. So, the absorption of radiation per atom of the stopping matter that is related to the number of atoms per unit mass of the matter. So, here the mass absorption coefficient, which we have taken the definition mu by rho. So, AU is equal to mu by rho into AL. Here A is the suffix, it is not multiplied. So, simply AU or A mu, not U, it is mu. A mu is equal to mu by rho into A by L. So, here the new terms are included that are capital A. So, capital A is equal to atomic mass of the atom, capital L is the Avogadro's number, and this AU is a atomic absorption coefficient and its unit is centimeter square per atom. So, the atomic absorption coefficient is related to the mass absorption coefficient, atomic mass, and the Avogadro's number, and its unit is centimeter square per atom. Now, we will see the fourth kind of the absorption coefficient, and that is electron absorption coefficient. So, LZ electrons per A grams, that is 1 mole of the substance. So, this is the definition of the electron absorption coefficient. So, again we know when we take any substance, in that substance Avogadro's number of molecules are present. So L is taken into Z. Z is the atomic number. So for any particular substance, the Avogadro's number of molecules will be present in that. So it is a L into Z electrons per A grams of the substance. So A grams of the substance means X, Y, Z, 1, 2, 3 and so on. So that gram of substance contains 1 mole of the substance. So the electron absorption coefficient for that E is suffixed to mu. So E mu is equal to mu by rho into A divided by LZ. So what is the difference between these two? Atomic absorption coefficient is equal to mu by rho into A by L, and here only Z is included. So Z is for the atomic number. Here E mu, its unit is centimeter square per electron. The absorption of radiation per electron of the stopping matter in the path is a fundamental quality, as the interaction of radiation is only with the electrons of the matter. So here the matter will interact with the radiations, and here the electrons of the matter are very important. They will stop the radiations which we have bombarded initially. So here the barn is most important unit to calculate the electron absorption coefficient. So 1 barn is equal to 10 raised to minus 28 meters square. So barn being a unit area, and that is equal to 10 raised to minus 28 meters square. So 1 meter square is equal to, we know, 10,000 centimeters square. So 10 raised to minus 28 meters square is equal to 10 raised to minus 24 centimeters square. So 1 bar is equal to how much centimeter square? It is 10 raised to minus 24 centimeters square. So this is all about the electron absorption coefficient, and its main equation is E mu is equal to mu by rho into A by LZ. Mu is a linear absorption coefficient, rho is a density, A is the atomic mass, L is the Avogadro's number, and Z is the atomic number. And unit of that electron absorption coefficient is a barn, and which is equal to 10 raised to minus 24 centimeters square. So we have seen the 4 absorption coefficients till now. Now we will see the absorption in water. So in the water we will again observe the 4 kinds of the absorptions. So first one is the linear absorption coefficient of water. Second is a mass absorption coefficient of water. Third one is a molecular absorption coefficient of the compounds. And fourth one is a mass absorption coefficient of the compounds. So we will see one by one here. So first is a hydrogen. So for the hydrogen, as we know, water contains the atoms. So initially we will find out the value for the hydrogen, then value for the oxygen, and then we will combine the hydrogen and the oxygen to form a compound, that is a water molecule. So initially we will see the hydrogen. So for the hydrogen, it is electron absorption coefficient E mu H is equal to 0.211 barns per electron. And the atomic absorption coefficient for the hydrogen, that is given here, Z into U mu H. So just multiply by the atomic number to the electron absorption coefficient of the hydrogen, we will get the value 0.211 barns per atom, because the Z of the hydrogen is 1. So mu by rho for hydrogen is equal to L by A into A mu H, which is equal to Avogadro's number into 10 raised to minus 24 into 0.211. So its value for the hydrogen is 0.1266 centimeters square per gram. So we found the mu by rho, that is a mass absorption coefficient for the hydrogen, and which was observed is 0.1266 centimeters square per gram. Then we will find out the mass absorption coefficient for the oxygen also. So that will be calculated as L by A into atomic absorption coefficient of the oxygen, and that is equal to 0.0636 centimeters square per gram, and the atomic absorption coefficient of the oxygen is equal to Z into atomic absorption coefficient of the oxygen. So we have the value of the A, mu O. So just put the value and the atomic number of the oxygen. So atomic number of the oxygen is 8. And just multiply it by the 0.0636 or atomic absorption coefficient, not 0.0636, but the atomic absorption coefficient of the oxygen is equal to 0.211. So we will find out the value 8 into 0.211, it is equal to 1.688 centimeters square per gram. So now we have two values for the hydrogen and for the oxygen, mu divided by rho for hydrogen and for the oxygen. So we will find out the further calculations for the compounds. So we have the absorption in water. So water is the main constituent of the human body or the human living beings, and they plays a very important role in a reactor technology. So mu is equal to 0.0706 per centimeter for the water for the quantum scattering, and the mu by rho of the water is equal to 0.0706 centimeters square per gram. So the mass absorption coefficient of the water is given here, 0.0706 centimeters square per gram, and here the density of the water, that is 1. So atomic absorption coefficient of water, which is equal to 0.0706 into A by L. So just put the mass of the water, it is 18, and divided by the Avogadro's number, and we want the atomic absorption coefficient in the band. So just divide the value by 10 raised to minus 24 centimeters square. So we will get the atomic absorption coefficient value, that is 2.11 barns per atom, and after that we have to calculate the atomic absorption coefficient for the all compounds. So atomic absorption coefficient for all the compounds, it is almost constant, and that is 0.211 barns per electron. And the way atomic and absorption coefficients of the other substances are calculated from this result that we have calculated here for the hydrogen and for the oxygen. So we have calculated E mu H, which is 0.211 barns per electron for the hydrogen. Then we have calculated A mu H for the hydrogen, which is equal to again 0.211 barns per atom. Here units are changed. For the electron absorption coefficient, the unit is barns per electron, and for the atomic absorption coefficient, the unit is barns per atom. Then we have calculated the mass absorption coefficient of the hydrogen separately, and which observes 0.1266 centimeters square per gram. After that we found the atomic absorption coefficient and the mass absorption coefficients of the oxygens, and the mu by rho for the oxygen, which is 0.0636 centimeters square per gram, and the atomic absorption coefficient of the oxygen, which we have calculated as 8 into 0.211, which is equal to 1.688 centimeters square per gram. Then we will calculate the third point, molecular absorption coefficient of the compounds. These are obtained by adding just the different atomic absorption coefficient. As we have the atomic absorption coefficient of the hydrogen and the atomic absorption coefficient of the oxygen, which we have calculated here. Atomic absorption coefficient of the oxygen and atomic absorption coefficient of the hydrogen. So by just adding this two, we will get the molecular absorption coefficient of the compound water. So molecular absorption coefficient of the water, that is a mu H2O, is equal to, as we know in water there are 2 hydrogens and 1 oxygen. So just multiply this atomic absorption coefficient of the hydrogen by 2 and the atomic absorption coefficient of the oxygen by 1, and just add these two terms. So A mu H for the hydrogen, which we have observed, it is 0.211 barns per atom. So just write value here, 0.211 into 2, because 2 hydrogens are there, plus 1 into atomic absorption coefficient of the hydrogen, that is 1.688 barns per or centimeter square per gram, or the barns per atom. This is the unit. So just write the value after calculation of this, and that value will come 2.11 barns per molecule. Here unit is changed from barns per atom. When only hydrogen or oxygen is there, you can write the unit barns per atom. But here the water molecule is there. So just write the unit or change the unit from barns per atom to the barns per molecule. So the molecular absorption coefficient of the compound of water that is obtained is a 2.11 barns per molecule. After that, we have to calculate the last calculation, mass absorption coefficient of the compound. So we have the water molecule or the water compound. So we want to calculate the mass absorption coefficient of the water. So mass absorption coefficient equation is mu by rho for the water, that is equal to 2 by 18 into 0.1266 plus 16 by 18 into 0.0636. So mu by rho, that is for hydrogen, which we have calculated, is 0.1266, and the mu by rho for oxygen is 0.0636. So just these values are written here, and the mass absorption coefficient is there, that's why ratio is taken here. 2 hydrogens are there in the mass 18. So 2 by 18 into the atomic absorption coefficient, or mass absorption coefficient mu by rho is taken here, that is a 0.1266. So the mass of the hydrogen divided by total mass of the compound into mass absorption coefficient of the hydrogen plus 16 is the mass of the oxygen, which is in the total mass 18, into the mass absorption coefficient of the oxygen, which we have calculated here, that is a 0.0636 centimeter square per gram. So that will be taken here. Just do calculation of these terms, you will get the value 0.0706, and unit will be centimeter square per gram for the mu by rho or the mass absorption coefficient of the water. So we have calculated all the values by combining just the mass absorption coefficient after weighing each atom in the proportion of its total mass in the molecule. So 2 is the mass of the hydrogen, because 2 hydrogens are there, divided by 18, it is total mass of the water molecule, into mass absorption coefficient of the hydrogen, plus in the second bracket we can take the mass of the oxygen divided by total mass of the water molecule into mass absorption coefficient of the oxygen. So by just adding two values, we will get the final value 0.0706. So what we have learnt here, so for the absorption in water, we will calculate the first mu. So mu for the water is given 0.0706. After that we have calculated the mass absorption coefficient, atomic absorption coefficient. Then we have calculated separately all the terms for the hydrogen. Then we have calculated all the terms for oxygen, and after that we have calculated the mass absorption coefficient and the molecular absorption coefficient for the compound water molecule. So by this way you can learn the absorption coefficient and absorption in water and their units for measuring the radiation absorption.